So for the next video, we're going to look at some review essentially for alcohols and a couple of new things. So remember from Organic 1 that alcohols, OHs, can be acidic or basic. And the pK for alcohols is a little higher than phenols. So phenols can be a little bit more acidic, and that'll be relevant a bit later on. And as they are, alcohols are not good leaving groups, OHs, if they were to leave as OH minus, that's a bad leaving group, Leaving groups need to be good leaving groups, Especially for SN2 reactions, elimination reactions, and those sort of things. But alcohols can be made into good nucleophiles by deprotonating, like we've seen with recent epoxide reactions, reminding ourselves of those. But we can also make alcohols into good leaving groups. And so one way we can do that is through this acid catalyzation, So starting from isopropyl alcohol here, we're taking ROH and we're going to make it into a good leaving group. So we can do that simply by adding some sort of acid to it, say HCl. And when we do that, this OH, of course, is more basic than HCl, so we generate OH2 plus. And now this is a much better leaving group, okay? And so what we end up doing, because remember when we have a really good leaving group like this, it leaves on its own, an SN2 or SN1 like reaction, okay? So this is SN1. Let's say we have a polar protic solvent here, to keep that all good and relevant. And so now water has left as our leaving group, H2O is an amazing leaving group. And now we have a carbocation of which, this nucleophile can come in, and finish the job. We can also do something similar where we have heat being used. And so instead of having just SN1, we can also do an SN2, or an E1 reaction as well to form an alkene. This is that acid catalyzed dehydration. Again, removing alcohol, dehydration, to form an alkene. So something else we can do, because this is relevant for SN1 and E1, What about for SN2, How do we make alcohol a good leaving group? So we can use these groups here, called mesyl or tosyl groups, to facilitate alcohol leaving. So how does this work? And this might be something you've seen in Orgo 1, depending on when you took it, but we're going to review it / cover it now, either way. And so what happens, So essentially alcohol will react with either one of these, They kind of function the same way, and it turns an alcohol into a really good leaving group. All right, so we'll cover that in just a second here. And I'm going to show you the mechanism, but you don't need to know it, okay? Especially looking here, Sulfur is a little bit different from what we've learned, Sulfur can expand its octet rule, which is why we're seeing it like it is now. So this alcohol attacks this sulfur, and what ends up happening is actually this carbonyl ends up breaking, and then it reforms, and then chlorine leaves as a leaving group. So it all kind of happens in one concerted step. And so the end result for this reaction here is this mesyl group is now attached to our alcohol, and chlorine has left as the leaving group. And so in this, in a second step, you can imagine, we just have this acid base step happening here, where now we've generated our neutral species. And so what's so important about this? You can see here the sulfur, it's electronegative. We have a lot of resonance happening here, The electrons on the oxygen are really being pulled away towards the sulfur and its corresponding doubly bonded oxygens. So that makes this now a good leaving group. And so now we can have a situation where we have a nucleophile come in, let's say Br minus, or really any nucleophile, can come in and remove this as a leaving group. And we can abbreviate this whole, we can abbreviate this whole sulfur business as just MS. Right, like we have up here, that mesyl group, right? And then you can see, right, this O minus attached to sulfur and these oxygens, there's a lot of resonance, so it's a very stable leaving group. Even though it's negatively charged, there's a lot of resonance that can take place to make this a really good leaving group. So this is what we can do, right? We can take alcohols, react them with, and they function the same way, tosyl groups and mesyl groups, to make these sort of protected, quote-unquote, alcohols, to make them really, really good leaving groups, again, for these SN2 reactions. So what else can we do with alcohols? A lot of them we've learned already, and I'm just going to kind of briefly discuss them here. I've included a list of where you can find these relevant reactions in the various chapters we've covered so far, right? But I'll discuss them here, and if you're good with what you already know, you can feel free to skip ahead. But right, these are 6 general alcohol synthesis reactions that we've already covered. Let's take a quick look at them. So right, we could do an SN2 reaction to form an alcohol, right, starting with something like, an alkyl halide plus OH minus, polar aprotic conditions. We can form alcohols like that. We can do acid catalyzed hydration of alkenes. So taking an alkene and then reacting it with acid and water. Right, we get this, Markovnikov addition, oxymercuration reduction, right, which is alkene, where we get a similar product, but it's very explicit for just one sort of reaction, meaning we don't get any side products. So with the acid catalyzed hydration, we could potentially get a hydride shift happening. Here we would not. Right, so, and we get this alcohol, again, Markovnikov. This other reaction here for hydroboration oxidation, that's those boron conditions, right, BH3, THF, H2O2, NaOH, and we saw this in that alkyne chapter as well, right, in particular using a bulky boron to make an aldehyde. But anyway, and this alcohol adds anti-Markovnikov, right, remember that? So this is an anti-Markovnikov addition of alcohol. And then chapter 5, where we had that dihydroxylation of alkenes, right, and in these conditions here, we added 2 alcohols across that double bond, right, and we added them syn. And then for this last reaction, number 6, which we just covered in our chapter 9 notes, if we have a acetylide, right, this negatively charged alkyne, and we react it with a ketone of some sort, or a carbonyl, right, so we can do a ketone, or we can even do an aldehyde, right, and we include an acid with them. We get the following alcohols. And with the aldehyde, we no longer have that second methyl group there, so we just have this. But so these are all the ways we've already learned how to make alcohols, right? And there's a lot of reactions that we just kind of have to sort of keep in mind as we're moving forward here. So we'll be touching back on them now and again. So these are all the reactions we've already learned, and so in the next video, we will go ahead and look at some new reactions to make alcohols or react alcohols with.